Welcome. Today we're going to solve the equation x squared plus 4 equals 0 and explore an interesting concept called complex numbers. Let's start by writing our equation x squared plus 4 equals 0. To solve this equation, let's first isolate x squared by subtracting 4 from both sides. This gives us x squared equals negative 4. Now, to solve for x, we need to take the square root of both sides. But wait, can we take the square root of a negative number? Let's think about what this means. Let's visualize why this is interesting. On a number line, when we square any real number, positive or negative, the result is always positive. For example, positive 2 squared is 4, and negative 2 squared is also 4. So if we're looking for a number that squares to give us negative 4, we need to introduce a new type of number called a complex number. We define the letter I as the square root of negative 1. Now, let's use this to solve our original equation. Taking the square root of both sides of x squared equals negative 4, we get x equals plus or minus the square root of negative 4. We can simplify this by writing it as plus or minus 2 times the square root of negative 1, which is plus or minus 2i. Let's visualize these solutions on the complex plane. Unlike real numbers which live on a line, complex numbers live on a plane. The horizontal axis represents real numbers, and the vertical axis represents imaginary numbers, multiples of I. Our solutions, positive 2i and negative 2i, are located 2 units up and 2 units down on the imaginary axis. Let's verify our solution. If we plug 2i back into our original equation, we get 2i superscript 2 plus 4 equals 4, I superscript 2 plus 4 equals 4, minus 1 plus 4 equals minus 4 plus 4 is equal to 0. In conclusion, we've learned that when we need to find the square root of a negative number, we can use complex numbers. The solutions to x squared plus 4 equals 0 are plus and minus 2i, which we can visualize on the complex plane. Complex numbers allow us to solve equations that have no real number solutions.